In this video I want to have some examples to see how to find number of protons, number of electrons, and number of neutrons, and how to calculate atomic mass or atomic number based on that. So let's have some examples. So argon has three naturally occurring isotopes: argon 36, argon 38, and argon 40. So these numbers mean atomic mass. So what is the mass number of each? How many protons, neutrons, and electrons are present in each? So as you see here, we have three isotopes. As you know, the top one is mass number. So we have 36, 38, and 40. We know mass number is equivalent to summation of number of protons and number of neutrons. So we know if we refer to periodic table, we can figure out that the atomic number of argon is 18. So the number of protons of all these isotopes are 18. So we write it down like that. So for finding number of neutrons, so we have 36 minus 18 is going to give us 18. 38 minus 18 is going to give us 20. 40 minus 18 is going to give us 22. So these are the number of neutrons. And on the other hand, we know the number of electrons and number of protons are equal for any natural atom. So as you see here, since we have three different isotopes, we have three different number of neutrons. Next example. We have, do both members of the following pairs have the same number of protons, neutrons, or electrons? So here we have two isotopes. Oxygen, atomic number is 8, and two isotopes, atomic mass is 16, and for the other one is 17. So they have the same number of protons and electrons, but different number of neutrons. So the first one has 16 minus 8, which is going to be 8 neutrons, and this one 17 minus 8 is going to give us 9 neutrons. So do both members of the following pairs have the same number of protons, neutrons, and electrons? So here we have argon, 18 and 40, potassium, 19, 41. So as you see here, the atomic number for both of them are different, so we can say the number of protons and number of electrons are different between these two numbers. So if we calculate the number of neutrons for argon, we have 40 minus 18, which is going to be 22, and for potassium is 41 minus 19, again it's going to be 22. So these two elements have same number of neutrons, but different numbers of protons and electrons. Next example, do both members of the following pairs have the same number of protons, electrons, and neutrons? So here we have cobalt, and this side we have nickel. So cobalt atomic number is 27, and here we have 60 for atomic mass. For nickel we have 28, and atomic mass is 16. So as you see here, the atomic number is different, so we can say the number of protons and number of electrons are different for these two elements. Let's calculate the number of neutrons. 60 minus 27 is going to give us 33. So 33 is the number of neutrons for cobalt. And here we have 60 minus 28, which is going to be 32. So the number of neutrons for nickel is 32. So these two are different. So they have different numbers of protons, neutrons, and electrons. Next example, draw atomic depiction for titanium. So titanium we have 22, which is the atomic number, and 48 is the atomic mass. So 22, it means that the number of protons in the nuclei and number of electrons are 22. For finding number of neutrons, 48 minus 22 is going to give us 26. So we have 26 neutrons here. Next example, we have selenium. 34 is the atomic number and 79 is the atomic mass. So 34 is the number of protons and number of electrons. 79 minus 34 is going to give us 45. So 45 is the number of neutrons. Boron. Atomic number is 5 and atomic mass is 11. So we have 5 protons and 5 electrons. 11 minus 5, which is going to be 6. So 6 is number of neutrons.